Thank you for taking the time coming here today to see our presentation. My name is Trần Văn Hùng from class 57AC1, and now I'm going to present my civil engineering graduation project, FLC apartment building. And my project would not be possible without the academic help of my academic supervisor, Master of Science Trần Việt Tân for construction design and for structural design, and Master of Science Phạm Nguyễn Văn Phương for construction design. My project consists of three parts. The first one is architecture, the second one is structure, and the final one is construction. FLC apartment building is one of 4 apartment buildings in Garden City, New Urban area, which is located in Đại Mỗ Quốc, Nam Từ Liêm District, Hà Nội City. And my study has 21 above ground story and 1 basement. The weight of the building in each direction is 25.2 meter. The length of the building is Y direction is 41.1 meter, and the total height of the building is 77.3 meter. The Babylon's building extends beyond 3 sides. It has beyond 3 sides of the building 6 meter, and the total floor area is approximately 21,000 square meter. In terms of the function of the building, the basement of the building is used for parking. From first floor to the 4th floor are used for retailing and services. The 5th floor and the 21st floor are technical floor, and from the 6th floor to 20th floor are apartment block. Each floor of apartment block consists of 10 apartment units, with the area varying from 48 square meter to 105 square meter. The vertical transportation of the building includes 2 staircases and 5 elevators. They are arranged inside the core of the building and go along the height of the building. Now I would like to move to the construction part. I will start to design the frame exit, structural frame exit A, the foundation under frame exit A, and 1 typical slab. For this building, I use frame called combined supporting system. The material that I use for the building is concrete B30, steel group A1, A2, A3, depending on the rebar diameters and structural elements. In terms of the preliminary dimension of structural elements, beam and slab are governed by the span of the building, while the dimension of column and other vertical supporting structure is governed by the actual load applied on them, and also the strength of concrete B30. In terms of the load applied on the body building, it consists of vertical load and horizontal load. The vertical load includes the cell width of the structure, the lead load, the load from the wall, and superimposed load. And while the horizontal load is only the wind load. And because the total height of the building is 77.3 meters, so I consider the impact of dynamic wind load into the design. So now, as for the slab design, because the height of typical floor is 3.2 meters, and the span of the building is relatively not 9.3 meters, and some location of the column grid line, there is no column under them, so there is a span from the edge of the core wall to the edge of the slab. This span is 12.3 meters. So I decided to, because of the reason and to ensure the architecture requirement as well as the high clearance of the building, I chose both techniques now as the snap solution for the building. The thickness of the snap is 25 centimeters, and I use the cable T15 with the diameter 15.22 millimeter. The cross section area is 1.4 square centimeter. The jacking force is jacking stress is 1450 megapascal. That equivalent to 80% of the strength cable of the cable. Strength of the cable. I designed both tension snaps in accordance with ICI 31808 standard with the add set software. And now moving to the foundation design. I would assign to design the foundation and the frame ICI, and after analyzing the feature of the building, also the property of the soil, I decided to choose ball pie as the solution for foundation solution for the building. For my assigned frame, I use the ball pie with the diameter of 800 millimeter. The pie tool is put 3 meter into the gravel layer, and the length of the ball pie is 41.25 meter, and the bearing capacity of ball pie is approximately 425 tons. And after select the diameter of ball pie and specify the bearing capacity of ball pie, I calculate the number of pie under each color, also the dimension of pie cut. Then I carried out the checking for bearing capacity for pie and shear failure and punching failure for the pie cap. Finally, I calculated the flexural reinforcement for the pie cap. I also provide the beam timing system collecting the foundation in order to improve the overall stiffness of the pie collection system. It also carries the load coming from the partition wall, reduce the distance settlement of the whole partition system. That also help to carry the bending moment for the pie cap with true pie 9.1. Now I would like to move to the final part of the construction design. I would assign to design the construction method, setting up the construction schedule, also design the construction site layout for the building. I use the cut-in steel construction technology, and the each floor for construction of each floor is divided into two phases. The phase one is for column and wall construction. The phase two is for beam and slab construction. Each floor is constructed one after another and from bottom to top. I use fixed steel formwork to design formwork for structural element, and use a prop, soaring and pound scaffold, like this one, to supporting the formwork system. I use ready-mix concrete for my building, and concrete is delivered from the station to the construction site by concrete mixing truck, and be poured by the stationary concrete pump associated with the concrete mixing boom. And for this, after I designed the construction method for my building, I defined the organization parameter to setting up the schedule, and then I carried out the design for the structural construction site layout, as I did display here in the construction drawing number 4. So that is it, all of my presentation today. Thank you for listening.
Well, let me ask you, because your presentation, signs, display, depending on the jokes of that video. How do you use it in your mind, the space? I recall that the jokes. The stories, or the word for the story. Based on what? And also that shows the basic, the basic that I don't know why. How do you do it? Okay, I got it. Oh yeah. Another question we have is, so how many type of relationship that you using? At this scale, how many types of relationship? And how the relationship between activity, Ram and Adam, you know, can you tell me that?
Use 3D analysis, right? After you have some first few months of the estimate, whether the moving structure is different. So the question is, I see here your landing layout, you provide equally all the way with it. You explain how do you install the landing layout into land? And you know the
So please explain the requirement and the consent for the pronunciation.
First of all, thank you for the questions. Now I would like to answer the question number one, the bifocal installation and how to determine the spacing between the port. Because of my snap solution is potent snap, so the snap has no interior beam. I only provided the battery beam to around the snap in order to improve the overall stability of snap, also to install the need entry for stressing. And because of this is about battery beam system, so
we call it battery beam, but the external beam we call it
yeah,
the external beam.
I guess I got it.
So it's battery.
So the exterior beam.
It's battery. Okay, that's what
Okay, so because the edge of the snap below the contracting snap is aligned with the upper one. So if I use the power scaffold, it's kind of difficult to install to make it right at the center of the beam here to support the stringer to support the bottom stringer of the beam. So I decided to use the probe because it's flexible, you know, because it's not only one probe and I can install easier. And because of one probe, is the disadvantage is that, but the power scaffold is more stable. So in terms to reduce the disadvantages, I provide the bracing between two sections, the section 1 and section here, as the part in order to improve the stability of the power system. And for the question how.
No, let me comment because okay, for the external beam is more difficult to ensure the safety. Why I see that you have a lot of cases on the solid you see the case. Why don't you use the case for the external beam? It's easy just to put it in place and don't need to solid it.
This case,
All the cases because you have to see look at it. At the very that is the case. Not the or here in Europe or Slovakia. Check.
Check as
Format, yeah. Format where the pages to the view.
oh
Let me see.
yes.
That's the case. See.
Ah.
Yeah. The view is more stable.
Yeah, because when I
For the
put
copy, the isolated copy, you have to hold it.
yeah right, I know that
So
guy.
you can put it at any time. So just put the case. Or it's stable.
Oh really? Because during the
Take a lot. Very dangerous.
yeah, I got the problem. That's it. During the time I doing for that part of my project, because I know that the can is much more stable than the prop individually, right? But
Yeah, and also.
I think that I provide a brace system so that it can.
Yeah, but
Yeah.
anyhow, you have to hold it
All right.
when you install it because.
Like because when I put the case, first of all, when I put the case in here, right, I want to align the center of the beam with the center of the case. So a part of the case would kind of it can be on the end of the snap. So maybe it can has go conflict with the hard scaffold system that I arrange around the building.
You use the control way because you have also the slab. You can transfer power the load the slab to that, and that it depends on how you design it.
Okay, yes, I got
Then you
it.
have you have the using the control way to make a balance with that.
Cut the weight.
Yeah, using the way of the slab or of the beam.
Yeah, I got the
So
yeah.
I don't think that you can do it, but difficult and also dangerous.
Oh right, because I avoid to extend the scaffold beyond the next of the slab.
Any solution? Yeah.
I know.
Just
Yeah.
make a calculation.
Yeah, thank you for that suggestion. Maybe next time we will do with that kind of problem, I will consider more solution for
So that means
to
the
choose.
practical, you need to get involved in the practical work.
Yes, thank you.
You can go and see around. They can do it.
Yes, this is kind of our weakness. We don't have any experience. Let's try to work on it later. Thank you. About the question about determining the spacing of what I call here is the top stringer and bottom stringer of the beam. I just calculate it's governed by two conditions. The first one is the strength conditions, and the second one is deformity conditions. So I do have to make sure that when the node apply on the beam and the scaffold system is strong enough to bear all the nodes, and it's not going to be collapsed by the node applying by pouring concrete into the beam. It also have to meet the requirement of the deflection of the bottom of the beam because we have the tolerance it specify the
So sorry because I thought I asked your colleague how to design the side beam.
the side beam.
The side
Okay, yes. First of all,
the side form work will be
the side form work will be
yeah,
that I
how
can
many
do.
times of course the acting to that.
This
How many times work?
the first of all is the lateral from the concrete while pouring concrete. The second one is a node by the equipment, for example,
The vibration.
the vibrator, yes, and also
What else?
the side form work.
And how about the wing load?
It gives
The wing, the acting against.
the window.
Yeah, how which element the city to that wing load?
I actually in my in my project I didn't consider the
You have to consider because when you work in Hawaii building, you have to, and also any kind of element and
so I will try to answer the question based on my limited knowledge. For example, if I consider the window to
okay, that's it.
yeah, thank you. The second question of you is the relationship that you for setting up the schedule. So as you can see here,
What's the kind of relationship between activity?
there are four types of relationship. Yes. and
That is enough.
there is that, okay. And the one that I use for my project is, as you can see here, the start relationship. With the blank here is the default relationship in Microsoft software. Yeah, finish to start, right? And the SM here is start to finish relationship with explain you later. And there are three types of relationship: the start to start relationship, start to finish relationship, and the default relationship finish to start. And the default is
Sorry, how that for type relationship, you have to consider what and how that can consider.
where it's have to based on the context method or
But something that is similar to the relationship, you have to add the terminology.
terminology. Yes, there's two factors.
Similar, but I have I type that you have to finish this
Before.
or as soon as possible. What is the technical terminology?
This is the technical, yeah,
You
technical.
have to know when to make schedule.
There are two major factors that govern this. Yeah, there is a kind of I want to explain the asset. Start to finish residual.
When you use as relationship, when
Because
when
for when I first of all in my project the tracing tendon for installing tendon activity I need to it can start when the tendon verification activity has done, right? Because in my project the tendon and the rebar are fabricated on the ground. So we know there is no conflict in terms of spacing parameter. So I just want to make sure that when I start to stretch the tendon, all the tendon has been fabricated on the ground. So I use that.
sorry, you have to look at the rate of progress of the two consecutive activities. So you have to look at the rate of progress. So depend on the decision whether you use the start or finish. And that is to relate this to the time plan.
Yes, thank you. And I would like to answer the question number 4 is how to know the building is so good after analyzing the 3D model and ADAS software, right? Well, after I define all the the dimension, the material and process and everything, and apply the load on the building, I run the analysis. And the first thing I have to be focused on is that the rigidity of the whole building that is solved by the displacement, horizontal displacement of the building, and also the story drift, the displacement between the floor, story drift. So I run right into the table of the result and check for the horizontal displacement and the drift story. When they meet the requirement according to Vietnamese standard, then I carry out the interval combination to identify the critical interval process to design threshold of rebar. Well, for my building is for example, the horizontal displacement over the total length of the building that smaller than one over 500. For my building, this is what I compare in my project. Thank you.
One more thing about the presence. So how to control the internal process
Internal process.
of the analysis result?
Yes, because during the time I modernize there may be some mistakes in terms of I check again and again for example the material, the processing over again, and then check for each snap whether all the load have been modernized or not.
Finally,
Yes.
when you got the hidden.
Positive, yes. I checked for two ways. The first one, I determine the electropositive apply on the node column because I know that the electropositive apply on each row, and I can easily calculating the node chamfering error for each column, and then by multiply them. For the beam, for the beam for my frame, I showing the moment diagram and also the zero diagram and even H04 diagram of my place, and I apply all my knowledge about the structures to determine whether something that straight or something that not right on my movement diagram or not. And then if it's something straight, I cannot explain. Maybe I ask my supervisor whether the reason for that straightness.
Okay. For the column is okay, not for the beam. So I think about the value of the movement.
The value of the movement, yes. Thank you. And the question number 5 is the tangent layout. Yes. For my class now, I apply node balancing method.
You explain here, you say, where do you put more tangent, where do you put less?
Yeah, I got it. Well, if I divided snap into the strips into perpendicular direction in X direction and Y direction, and then I run the same software to determine the moment caused by the cell width of the snap on each strip, and by applying the node balancing method, I to be at 90% of the moment caused by the cell width of the snap, and then I got and then apply node balancing method. I determine the primary quantity of tangent on each strip, and then I arrange the strip tangent on the strip based on the requirement in terms of the spacing between strips, the minimum and maximum. And there's the notification for the arranging the tangent is that I have to, because the tension moment that on the column as the column area not usually very enough compared to the positive moment as a middle span of the snap. So I had to careful check on try to reduce the tensile stress as low barrier as much as possible. So because of this reason, so I arrange the tendon close to the snap, so that the effect of tendon can reduce the tensile stress at the top.
Explain more clear. Here you put more, or here you put more, at the middle or above the column.
Yeah, because the position in column and silver position, the negative moment is much narrower than the positive moment at the middle span of the middle strip. Because I use the node balancing method, so because the moment is natural, so I need to add more tendon in order to reduce the tension stress at the position. This is the reason why the tendon is on the column strip normally more than the tendon on the middle strip. This is thank you. And about the question about the steer.
That's okay.
Thank you very much.